Hello everyone, let's study about the force law for simple harmonic motion. To understand this, let's recall the expression for simple harmonic motion mathematically. So A is equal to minus omega square into y represents equation for a simple harmonic motion. You can also write A is equal to minus omega square into x. Both are acceptable. The only thing is A is equal to minus omega square into some kind of a displacement. This is what they get for a linear motion. Now in this case, if we multiply by m on both sides, m here and m here, then m into a is called as force. So this becomes F is equal to minus m omega square into y. For a given motion, both m and omega are constant. Therefore, we can write F is equal to a constant which is called as minus k into y. This k is a constant and that k is equal to m into omega square. As given here, this k is a constant that's called as a force constant. Now this equation is called as the equation in the bracket. This is called as force equation for a simple harmonic motion. So any simple harmonic motion, whatever the examples, whatever the cases are, whether it is motion of the particles of air or simple pendulum or any kind of simple harmonic motion, if any object, if any body is executing simple harmonic motion, then for that motion the force would be of this form only. This is called as force law of simple harmonic motion. Now from here, let's find what is time period for simple harmonic motion. Now we know that time period is equal to 2 pi by omega, but omega from this expression, from here omega square is equal to k by m. Omega from here is equal to under root of k by m. Therefore, t is equal to 2 pi by omega. Omega would be under root of k by m. It goes on top. Therefore, frequency is equal to 2 pi under root of m by k. So this is the expression for time period where k is a force constant. Now based on the conditions, k could vary. Now in this case, k is one form. If it's say a torsional pendulum, something of this kind, there k plus some other form, there will have rotational motion. Think for example, say we take water and then we take for example say wooden cube and press and leave it, it may oscillate by simple harmonic motion. The k would change. So the form of k would change based on the conditions, but for any general motion the time period is given by 2 pi under root of m by k. Frequency is equal to 1 by time period, that will be 1 by 2 pi k by m. So this is what is the frequency for simple harmonic motion. Now here we can write this time period in other form also. Now to understand this, recall that we know that F is equal to k into y mathematically. Now in the previous expression what we wrote is, we wrote it as minus k into y. The minus sign indicate that it's restoring force, because in the expression for A, which was given as minus omega square into y, this A, the minus sign indicated that acceleration is always opposite to the displacement. So we can think that the minus sign indicates it's always a restoring force, but its magnitude, its only value, right at F, that will be k into y. We also know that from here we can say that k is equal to F by y, but F is m into a. Recall that the force is always seen as m into acceleration. This is the consequence of the force acting, not the cause of it. Wherever the motion is, whether somebody kicks a ball, whether some chair is pulled, whether the car is moving. In all the cases, the consequence is given as m into a. So this is the effect of force. This is the effect or consequence of force. The cause could be different. So putting that here, what we get is, we get k is equal to, it will be m into a by pi. But recall what was t. T was 2 pi. Go back and look at it. 2 pi m by k. So it becomes m by k under root. So from here, if you write m by k, so it becomes y by a. So y by a is equal to m by k. When we put it back here, then we get time period is equal to 2 pi into y by a, where y is the displacement and a is acceleration. So there can be instances where the force, the time period would be in this form also. So this is another form of time period, where we write time period in the form of displacement and acceleration as given here. So t is equal to 2 pi into under root of displacement by acceleration. So this is other form of time period. Similarly, frequency is 1 by time period. So if you write it, we get frequency is equal to 1 by 2 pi under root of acceleration by displacement.